Hi everyone. Today's lecture is about air masses and fronts. Before I start my presentation today, I would like to remind you that the grades for exam 1 has been are posted now on iCollege, and I think generally on average, like, everybody did well. And but if you haven't done well in the first exam, of course you'll get you still have three more opportunities for you to do well and score the highest possible grade in this course. So we'll have exam 2 next week, so I'll keep posting all the relevant materials today, starting from today. And as a reminder, of course, once this lecture video is uploaded today, the attendance quizzes also will be posted as soon as the lecture video is posted. And of course, if you check your syllabus, and we have one more lecture to go before the spring break, and then we have our second exam on Wednesday next week, and it will be very similar in format and content very similar to the first exam in terms of format, but the content will be different this time. Of course, only have questions from the last 4 or 5 lectures that we have covered, right? So also encourage you to go through the syllabus, and then also, of course, post the study guides in the next day or two, right? Okay. So there will be many questions about air masses and fronts, and of course, like you have done so already in previous lecture videos, I encourage you to follow the lecture video, to watch the lecture video in full. And so it's also very important, and part of today's discussions we have already been a little bit covering a little bit in the previous lectures as well, right? So these are the key terms and then key concepts that we're going to cover. We'll start with temperature and specific humidity, and then the different types of air masses that we have and how they are different from each other, right? How we'll compare and contrast the different air masses that are the four important air masses are listed below: the maritime tropical, continental tropical, maritime polar, and continental polar, right? And then before the end of today's presentation, of course, I'll talk about fronts, the different types of fronts: cold fronts, warm fronts, and then occluded fronts, right? So let's get started with air masses. Well, air masses are simply large volumes of air with uniform characteristics, right? So we're looking at temperature and moisture. These are the two variables that we're looking at to characterize an air mass, right? So think of it this way: we do have different oceans, right? And for instance, how we differentiate the Indian Ocean from the Pacific Ocean, we look at certain characteristics, right? For instance, salinity, right? Difference in salinity. In the same way, when we're looking at the atmosphere, we actually categorize different air masses by specifically looking at temperature and the moisture content of these air masses, right? And also we look at where they originate from, right? So if you look at the names here: maritime tropical, continental tropical, maritime polar, and continental polar. These are the four types of air masses, at least the dominant ones. So if the maritime tropical, it tells you that, like, well, it comes from the ocean. If the air mass is originating from the ocean, it would have the maritime initial, while if the continent is the source, like the continental polar and continental tropical, it would have the continental added to its name, right? So both we're looking at temperature and moisture, and also where they come from, right? So there are 4 very important types of air masses, right? And a small one you'll see in the next slides, but these are the most important ones. We have the continental Arctic and the continental polar, the maritime polar and maritime tropical, right? So the difference between these different types of air mass is like, for instance, if the air mass is maritime polar, that means it's coming from the ocean. So how is it different from maritime tropical? Well, it's not coming from the tropics, right? It is actually sourced from oceans near closer, relatively situated, closer to the poles, right? So it's polar. So what does it mean? So if it is like closer to the poles, then the maritime polar air mass is humid, contains a lot of moisture because it's coming from the ocean. It's cool, right? And because it's relatively positioned closer to the poles compared to maritime tropical. But I would also, as I would explain in the next slide, it's also unstable, right? We'll cover in the next slides how we categorize air masses and movements of air as stable and unstable. But if we're looking at continental Arctic, right? Continental Arctic air mass, it is very, very cold, very dry. Why is it dry? Because it's actually not coming from the ocean. It is coming from the continents, right? These are very cold, very dry, and stable air. So what's the difference between stable air and unstable air, right? So what did I say in previous lecture? Typically, you would expect the temperature to decrease as you go up in altitude, right? So what happens is that if you have, for instance, a warm maritime tropical, a warm air mass coming in from somewhere else, right? And which has relatively a warmer temperature, right? Much warmer than the surrounding air, then it would actually occupy a certain space in the atmosphere, right? And then it would cause temperature inversion, right? So typically that means you wouldn't expect warmer temperatures to exist as you go up, right? So because of this temperature inversion, if we do have temperature inversion in the atmosphere, that is, if the temperature does not decrease with altitude, with height, then we have, that means unstable air, right? While if there is just like a cool air and then cooler air, much cooler air above it, then what we have is stable conditions, right? So the two very important variables for air masses are temperatures and specific humidity, right? So these are, and then both temperature and temperatures and specific humidity change with the seasons, right? So the air masses are also changing with the seasons, right? So for instance, in Atlanta, the type of air mass that that dominates Atlanta and surrounding areas is much more different during the winter season compared to the summer season, right? So for instance, during the winter season, the air is very dry, right? Because it is dominated by the continental polar air mass, that is the cold air coming from the poles, which is because it's sourced from the continents, the air is relatively dry, right? So that means the specific humidity in large areas of the U.S. of many places in the northern high latitudes, or like in the northern hemisphere, they tend to be the specific humidity is much lower, right? While during the summer season in Atlanta, for instance, it is it's very, very humid, right? Because warm air, more maritime tropical air from the Gulf actually is dominating large swaths of land in the US, in continental US, right? But we also have what we call a smaller, relatively smaller type of air mass that we call continental tropical. These are hot. This air mass is characterized by hot temperature. It's really hot, but it has lower relative humidity because it's continental. It's sourced from the continent. So the continental tropical. So these are dominant air masses in places like Arizona, New Mexico, right? Very dry. So they are shielded by mountains from the ocean. So it's actually, they don't really have the maritime tropical air masses don't really penetrate and reach these areas, right? These parts of the US, while the maritime tropical air masses are much more dominant during the summer season in places like Atlanta, Florida, and also surrounding areas, right? So if you look at summer temperature changes, for instance, I'm showing you here data for June to August from 1988 to averages from 1988 to 2017. So what you see here, while during the summer season, temperatures are much warmer, also the specific humidity is compared to the winter season much higher because there is a lot of moist air, maritime tropical air that is dominating large areas of the United States, right? And so if we look at the winter to summer change and winter temperature, of course, typically you would expect the temperatures to be very cold in many parts of the US during the winter. Of course, that's typically the case, even if we do have change in the duration of the winter season as a result of the global warming, right? But part of the natural variability is that we do have these seasons, and then temperatures are expected generally much colder during this winter season compared to the summer season, right? And with that, we also have change in specific humidity, right? So specific humidity, whether it is hot or cold in a place, it actually influences whether we should expect higher specific humidity or lower specific humidity, because the seasons also influence the outreach of these different types of air masses, right? So summer specific humidity in many places in the US, it's like, well, of course, we do have also relatively drier spots, but of course, specific humidity is also influenced by the conditions like topography, right? As you go higher and higher, the specific humidity decreases. The amount of water vapor available in the atmosphere decreases as you go higher and higher. So there is, of course, obviously differences across topographical scale, right? So, but typically what happens during summer season is more and more places in the U.S. are dominated by the warmer air and moisture rich, as you can see here, more warmer and moisture rich air mass that is the maritime tropical pretty much dominating many places in the US, right? So if I ask you which season has the largest north-south gradient over the United States, given this is actually I'm sorry about the typo. This doesn't make sense. But what I wanted to ask you was which season has the largest north-south gradient over the United States? If you're looking at in terms of air temperature and specific humidity, we have a large gradient during the summer season compared to the winter season, right? So what if what type of air mass? If I ask you what type of air mass is present always at the ITCZ, remember this intertropical convergence zone, or in short, the ITCZ, is pretty much represents the hottest part of the planet in any given season, right? So what do you expect? Well, maritime tropical air masses are very, very dominant because, well, it's hot and then we're actually not very far away from the ocean. So there is a lot of abundant moisture. So the air mass is present. The temperature is like very warm. Two, and then there is also abundant moisture, and then it would qualify as a maritime, enough to qualify it as a maritime tropical air mass, right? Okay, but the continental polar and the maritime polar, well, both are like relatively colder, right? Because they are actually situated closer to the poles, but the continental polar is a cold, dry, and stable air mass, right? And its source regions are Canada and Siberia. These are really very, very close to the poles. While the maritime polar, these are warmer and relatively warmer and wetter types of air masses compared to continental polar, because they are wetter, because they come from the maritime polar, the maritime region, even if they are relatively closer to the poles, but there is abundant moisture available. So the maritime polar is always going to be warmer and wetter than CP or the continental polar, right? Again, so during the winter season, for instance, that's the reason, one of the reasons, so why we experience really cold days sometimes. So there is, of course, the movement of the continental polar air mass, this intrusion, cold air intrusion. We had similar cases in December. So daily temperatures were as low as in Atlanta, but as low as 6 degrees Fahrenheit, right? Very close to 0 degree Fahrenheit. So that means this happens when cold, dry air mass like the continental polar intrude and actually dominate large areas across latitudes, right? And while when we have, for instance, the maritime polar dominating a region, what we have is these are cold and moisture-rich air mass. So you would expect, well, it would still be colder, but like cold and wet weather would be much more prevalent when the continental, the maritime polar air dominates. So in a way, the maritime polar is a modified version of the continental polar. So in a way, the major difference is that the fact that the continental polar air it doesn't really contain a lot of moisture, while the maritime polar air mass contains a lot of moisture, right? So there is similarly that differences between continental tropical air mass and maritime tropical air mass, right? So again, as you can understand from the name, it's continental, so it comes from the continent. So it's easy to expect that the continental tropical is much more drier than maritime tropical air mass, right? Because the maritime tropical air mass, it has its source in the ocean, right? It's sourced from the ocean, and while the continental tropical air mass dominates subtropical deserts like Arizona, New Mexico, those places, those regions, while the maritime tropical, it really dominates like large areas of the U.S. like Atlanta, Florida during the summer season, where you feel there is a lot of moisture, so it would feel really hotter than it is, and because this maritime tropical air mass is much more dominant during summer season and brings a lot of moisture and warm air with it, right? And so if I ask you which of the following air masses should have the highest specific humidity, especially during the summer season, remember the highest specific humidity represents where the air mass with highest amount of water vapor in it. So it's always going to be the maritime tropical. The maritime tropical is the air mass type with the highest specific humidity and highest temperature, while the temperature, the continental tropical air mass, it can be as hot as the maritime tropical, but it's extremely dry. So the specific humidity differences is what differentiate the maritime tropical air mass from the continental tropical. Right. Okay. So when we're talking about fronts, I'm jumping to fronts here, and when we're talking about fronts, when we're talking about fronts, it's actually closely associated with the type of air masses, because what we consider a front is simply the boundary zone between a warm air mass and a cold air mass. Remember, previously we defined the jet stream as the meeting place between a cold air mass and a warm air mass, right? So simply put, a front is a boundary between a warm and a cold air mass, right? And of course, the position of the front changes with the seasons, because we do have changes in temperature, both in temperature and specific humidity throughout the years, right? So that boundary, it's always shifting throughout the seasons, right? So if you look at monthly temperature change, of course, significantly colder, typically in January, and then it's always getting warmer, right? And typically it's very warm, right, in February, but more and more, especially in places like Atlanta, we're experiencing very shorter the winter seasons, right? So it's also we can consider it a manifestation of the heating up of the planet, right? Many places, like the spring starts early because pretty much the planet is heating up, right? So typically we have, as we go to the season, then of course temperature increases, and then we have that natural cycle, the seasons, right? And then of course this also impacts the position of the jet stream. Remember, the jet stream is the meeting place of two different air masses, right? It's where two different air masses meet. So for instance, during the summer season, the maritime tropical air mass, right, that warm air mass, actually much more dominant and then pushes the polar jet stream further to the north, while during the winter season we have the cold air mass coming from the poles that's much more dominant. So the position of the jet stream changes with the season, right? And again, if we look at the changes in specific humidity throughout the year, then we have, of course, typically January is the driest month. While not necessarily the driest, but the specific humidity is very low. The air is typically dry and across many places in the northern hemisphere, while it gets better in February, March, April, and then we have the highest specific humidity typically recorded in many parts of the world in July, right? There is a lot of, and so typically July may feel much hotter than the rest of the months, because the air carries a lot of moisture, especially for the places not very far away from the ocean. Then this is the months where the maritime polar the maritime tropical air masses are much more dominant compared to the winter season, right? And then we do have these cycles, of course. With it, we do have changes in the position of the fronts or the polar jet streams, because as the air masses the air masses change with the seasons, and then of course the area they dominate changes. Of course, the position of the jet stream as well as those frontal areas change with the seasons as well, right? And again, when we're talking about fronts, simply we're talking about the boundaries that separate the air masses with different temperature and other characteristics. Most importantly here, we're not just, we're mainly looking at temperature change. And then these are most common in the mid-latitudes, because that's that's typically the meeting place between these different types of air masses, right? Because, like, for instance, tropics, while like we don't really have significant differences in temperature, and then we don't really have those cold air mass intrusion near the tropics, right? It's just warmer throughout, right? And then while in the mid latitudes, we have this complex interaction between different air masses. So as a result, the fronts are actually much more common in the mid latitudes. So there are three types of fronts, and all of them important. And these are the cold front, the warm front, and the what we call the occluded front. But I'll start with the cold front first. This is what we call a cold front is when we have a condition where a cold air approaches horizontally and replaces an existing warm air, right? So by doing so, what we have is typically what we call this cumulonimbus cloud formation, right? It really pushes that warm air that contains abundant moisture in it. It pushes that warm air with a lot of moisture to vertically upward, and then we end up having those what we call the cumulonimbus clouds. So what happens is that heavy thunderstorms would take place, because then there is a lot of moisture that's being pushed to the atmosphere, and while we have these cumulonimbus cloud formations, which actually, if you look at these type of clouds, they actually occupy large areas vertically, right? And then they do contain abundant moisture, and as a result, then it's very favorable for thunderstorm formations, right? And typically, so when you see cumulonimbus clouds here in Atlanta, what happens is that a cold front, right? A cold air, relatively cold air, is pushing the warmer and which moisture-rich air and vertically to the atmosphere, and then as a result, it's typically associated with heavy thunderstorms. And the opposite is true in warm fronts. So what we have is warm air mass, and then kind of gradually moving over a cold air mass. Remember, for the cold front, it is the cold air mass replacing the warmer and moisture-rich, pushing away the warmer, moisture-rich air mass, while for warm fronts, what we have is the gradual transport of relatively warm air mass through the cold air mass beneath. So what happens is, as they do, as the air stabilizes, we have this changing cloud formation from nimbostratus to teeniest clouds that we have top of the atmosphere, the cirrus clouds. And while the warm fronts, they are typically associated with moderate precipitation. They're not as violent as cold fronts, right? And then we do have what we call occluded fronts, and this is typically the occluded fronts form when cold front catches up to a warm front, and then the warm air gets pinched off from surface, right? So in a way, the occluded fronts are actually very similar to cold fronts, right? So what we have is typically the cold air pinches off the relatively warm air with moisture if it is a warm moisture rich. So what happens is like thunderstorms, we do have can have very heavy rain, especially if the air mass that's pinched off from the ground contains is warmer and then contains a lot of moisture, then heavy precipitation is expected. While the air that's pinched off from the ground is colder, relatively colder, and is not and then even if like it's moisture rich, and then what we expect is like light rain for some time, right? So like if I ask you why fronts are located closer to the poles during the summer season than during the winter season, remember whether we're talking about fronts or the jet streams, there is a constant changing in direction and position across the seasons, right? So what happens is during the summer season, for instance, the maritime tropical air mass is very dominant, much more dominant than the winter season. So of course the boundary between the warm and cool air moves polarward from summer to winter, right? So in a way, I'll before I end, I want to show you this figure again. I want to end today's presentation with this figure. So what happens is that, of course, when we have the maritime tropical air mass dominating large areas during the summer season, what we have is the meeting place. That is the boundary where we have the fronts, right? Where the cold air mass from the poles meets the warm air mass from the tropics, moves northward, right? Think of it that way. With that, I end today's presentation. And again, we have one more lecture to go on. I believe it's about weather forecasting on Monday, and then of course exam 2 will be posted on Wednesday, and then you'll be given enough time to complete 30 or 40 questions. I haven't really decided whether to have 30 questions or 40 questions, but I'll let you know in the next days. But please make sure to check out your iCollege, the courses page on iCollege, and I'll continuously post relevant materials today, tomorrow, and the next days. And also a reminder again, the attendance quiz will be posted today, and I'll post the last lecture video on Monday, and then we have exam 2 on Wednesday. Right. Take care, guys.